Thank you all for attending. So yeah, I'm currently a developer advocate at Blackfire and Platform SH, since Platform SH acquired Blackfire, and I assure you that it's all fine, and because yeah, it's also an awesome company, so that's fine. And yeah, I will talk about Blackfire. I can talk about Blackfire for hours. I try to keep it quite short. As I could see, a few of you already are already using Blackfire, which is really awesome. And I'll try to cover first the profiling. So Blackfire as a profiler, because it's originally a profiler for PHP, but now it's also a monitoring system, so an APM. And so I will take you on tour on what how it looks like and what you can do with it. So I'm going to start with a small presentation. So a few slides. Where is it? Here. Right. So yeah, Blackfire demo. Well, usually you use Blackfire because you care about performance. And for whenever performance is a subject on a table, is because you care about you care about it, of course, and it means that you need to use certain tools in a domain that's called observability. It might be obvious, but it's better than when it's said that web applications, their performance has a direct consequences on any company's revenue. And this is a statement. This is not a statement that out of the blue. Several researches has been conducted by very large and major companies like Akamai or Google or Amazon, and that all showed that the user engagement and thus the company's revenue is directly correlated to performance. The two numbers that are shown here: 53% of users abandon a site that takes more than 3 seconds to load, is something that we should always keep in mind. And here, 3 seconds, it means end to end. So from the request to the displayed response. So and it tends to get lower and lower, because we're all getting impatient to get a response, right? So we really need to, as developers, back end and front end, keep that in mind absolutely all the time. The other number, it's more something that Amazon found out on their store, is that improving by 100 milliseconds only the page load time always increase conversion rates by 7.1%. And this is like mechanical. It goes when you reduce the time by 100 milliseconds, and also the opposite. So you lose 7% average when you increase the load time. So yeah, that's the state of it. Now what? The thing is that we as web developers, we usually don't have the right tools to understand what's going on. and where in our code the performance bottlenecks can be. And this is actually a problem because you cannot improve what you cannot measure. This is a motto that we have at Blackfire. Without facts and figures, you cannot improve anything. You cannot improve just saying, yeah, it looks faster. This is not enough. You cannot actually know what if the fix you made really improved the performance if you're not able to measure it. And a tool like Blackfire is made precisely for this. And the image here is pretty accurate. It's precisely like getting glasses, putting glasses on to see what's going on within the application. We need to separate the idea of code and application to clearly understand what a profiler is for and what all observability tools are for. The code, you can consider the code as the blueprints of an engine, a machine. You can analyze the blueprints to detect flaws. This we can do with static analysis tools like PHP-Stan or Symfony Insight. But the code is not running, right? It's purely static. Once it's running within the PHP FPM engine, within the web server, then it becomes a black box. Because it's like the engine that has been ignited, and you cannot see anymore what's going on. And a profiler is made precisely for this. It gives you these bionic glasses, giving you the ability to actually see how different components of your application are interacting with one another. And this is really precious. It's like, having the supervision from Superman somehow, giving you this ability. Well, I will be very fast on this one. Of course, when solving a performance issue or any issue costs a lot less when you're close to development than when you reach production. As developers, we probably all know that. Well, at least I assume that we are. That's, yeah. Try to identify performance issues as early as possible. And well, Blackfire covers the complete development cycle, from development to production, and going through testing as well, testing and staging. In development, usually you will use the Blackfire here, most likely the profiler, to debug, to understand your application. Like, imagine that, yeah, you're working in an agency, you're getting a new project from another agency or from a client who worked with another agency. So you don't know anything about it. And here, Blackfire will help you understand how the application is built and how it works. This gives me the opportunity to tell you that actually a profiler is not really much about performance, but about behavior. You analyze the behavior of your application, the performance being an aspect of that behavior. So of course it's important, but it's the behavior in general. So it means that you can and you should use a profiler as a development tool for debugging. Debugging in development, on staging, and also on production. because this is one of the key advantages of Blackfire, is that it has an on-demand model, meaning that when you set up Blackfire as you set up the probe, so the PHP extension that gathers all the data on your PHP FPM, by default it does nothing. It stays completely inert. And this is completely the opposite of what does XHProf, for instance, or Xdebug Profiler. Because once you enable XHProf, it's virtually on for any request. So you cannot you cannot have this in production because of the overhead that is being generated. As you're measuring something, you're always having overhead. This is inevitable, and it's also the case for Blackfire. But the difference is that by default, it stays inert, and you can trigger a profile using this browser extension or a CLI command to do a profile. And once the PHP engine receives a profiling request, well, then the probe says, okay, that's my job now to gather all the measurements, and it does everything. You have this this overhead, but it won't impact any of your users. The overhead will only be for yourself. So that makes it eligible to production, and we really encourage people to install this in production. And of course, now it's been a year now. We released also the Blackfire monitoring. So it also goes through the same PHP extension and with a very minimal overhead, which is really negligible. But I'll cover this later. And about testing and staging, you can also automate the usage of Blackfire by using scenarios, defining scenarios, a bit like what you would do with Behat or Symfony web test case, for your functional tests. And actually, you can do functional tests using Blackfire builds as well. The difference is that for all those scenarios, for each step, you will have a profile. You will get a profile. And you can use these profiles to run performance tests and define performance tests that will be assessed in each and every profile. So getting a whole automation that you can, for example, connect on your GitHub pull requests to validate if you did not introduce performance regressions. Now, let's talk about the different collection levels. So as I said, now we have Blackfire monitoring and Blackfire profiling. And these two features work together, here, assuming that we're in production. So monitoring is all about collecting traces. So a trace is basically a request coming to your application, to the reaching PHP, going through your application, so processing, and then eventually giving a response. This generates a trace, and a trace collects some information like the general time, the wall time, the amount of memory, the server load, and also the bandwidth that has been used, and also the location in your application. So that's what we call a transaction. Transaction is a trace that has been identified within your application. So in the case of Symfony, it would be just a controller action. We also have extended traces. So extended traces are, so they have a bit more overhead because we go a bit deeper to collect more information, live information like interaction with the database, giving you the opportunity to identify SQL requests, which are which SQL requests were the longest, or the interaction with your Redis server, or with your RabbitMQ server, or your Elasticsearch, whatever. So this is what we call services monitoring. And this is collected thanks to extended traces. And it also gives a bit more information about the key components that from your application, like the controller or the PDO statements and stuff like that. As they generate a higher overhead, which has never been measured higher than 10%, so which is quite reasonable. By default, it represents only 1% of the global number of traces. These metrics gives you answers to two questions: when and where. When, because when do I have a performance issue? Because it's recorded, right? You have a retention of those traces, giving you the opportunity to see over time how your application responded. And where, thanks to the transactions that are automatically detected most of the time, but for Symfony and major frameworks, they're detected automatically. So you know precisely which controllers have your users have been using. But you're still missing the why question, and this is what the profiling, the profile is for. Profiling goes as deep as it can be because it's deeply connected to the PHP engine, and Blackfire will measure each and every function that is being executed by your application, giving you a call graph that I will show you in detail. This is a call graph. Each node here represents a function call or group of function call, and so it's all about interaction with the different functions. It gives you a very precise overview of how your application is behaving, and it gives you tools to identify potential bottlenecks. So it doesn't directly give you the answer to the why question. Why did I have this issue, this performance issue? But it gives you enough hints and tools to understand what happened. Okay, so now let's take a metaphor. Imagine here, so traces, they're actually like traffic at city scale, live. You know, so this is the Paris area. It's being recorded every day, and you can see the evolution of traffic. Well, this is what traces are. You have an overview, a global overview of what's going on and where it's going on, and also when, because it's recorded. You can travel back in time. And well, we have here ideas where we have issues. Like here, we can see that yeah, it's quite heavy traffic in several roads that are closed, etc. But not so many details. But still, we have important information here. Extended traces would be the traffic at the street scale, still live, still recorded. So here we're at the level of the neighborhood. We can see which streets has been closed, which is close to this church, etc. And the profiles would give you the street view. So with all the details and advanced insights. So you can see that this is this road that has been closed, and you see here why, because of road surface renewal, etc. And Blackfire also gives you actionable performance insight, but we'll see that in a moment when I show you this all these features. So that's it for the presentation, which was long enough. So now let me show you a bit of Blackfire profiling. Usually I start with monitoring, but I think for this presentation, it makes more sense to discuss about profiling. Here, this is the Symfony application, a very small Symfony application that is basically like a blog. This is the Sasquatch sightings club, so people that are tracking the Bigfoot in North America. So they founded a club to track or to stalk the Bigfoots, and so each post here is actually a Bigfoot sighting of the Bigfoot itself. So it's basically an article with different different comments. No big deal here. It's just that it's written in Symfony. Now let's do a profile, because let's say I've been said that there are performance issues, so I need to understand what's going on. So clicking on profile here, actually we're taking 10 samples of the same page for profiling, so to have a proper average of what's going on. And then I have the first summary of the profile. You can see these different numbers. The first one, these are called dimensions. The first one is the wall time. So wall time is a fancy word for time, which is split into two flavors. The first one is input-output. So everything that PHP is waiting for outside of it, like database interaction, file system interaction, stuff like that. And CPU time. So this is the time spent by PHP actually computing something. Memory usage. So here it's the peak memory, network bandwidth, external HTTP requests, and SQL queries. We also have two different views of this profile, a timeline and a call graph. So I'll start with a timeline. Right, probably zooming in. So this is a timeline. Actually, usually I start with the timeline because this is how I represent how the application is running, how the application on a time base, goes from A to Z, from the index.php to the response that's been given to the client. And well, usually it's a good representation of what we developers have in mind. Each block here represents a function call. Some are colored because they're being highlighted and detected as key metrics, like here, Symfony controller, or templates themselves. So we can go directly down to the template, etc., etc. And each block length is proportional to the time spent within that function. And they're stacked down because one function calls another, which calls another, etc., etc. So, and the deeper you go, the more complex your application is, because it goes, well, a lot of function calls. Here, there are not so much, but imagine Magento. Magento is huge. It's like the Marian pit with a lot of function calls. Well, I can zoom in to see what's going on, because actually we can see that it's the main controller that's getting like 300 milliseconds. That's quite long for a controller. So we can zoom in and to try to figure out what's going on. Yeah, we have like doctrine hydration, which occurs actually quite a lot of times. So we probably have something here. If I click there, well, I have the whole call stack, and I can check what's going on. Maybe you already spotted it, because the game after that, once you have these kind of things, is to spot the function that's actually from your code. So here, for example, that's the case for the common helper, which is being called by the app extension. Here, a twig extension, which itself is being called by this template. Well, we already have something here to chew on. Something else, the blue graph in the background represents the peak memory envelope that is increasing over time. It's really useful for memory leaks detection. Really useful. So always keep an eye on this. And yeah, this view gives you actually a good starting point to detect performance issues. Usually the lowest hanging fruits would be easily spotted in the spotlight thanks to this. Right. Now let's have a look at a call graph. So the call graph is this. And if I change, no, I cannot move this. Yes, I can. I have a very small window. And if I click on the different dimensions, you can see that the call graph has different aspects. Memory here, or even the bandwidth. This is important when you do a profile to move over to change the different dimensions, because it gives you information, but in a different way. It gives you an insight of the different insight from different aspects of your application. So if I look at, here input output or CPU, you can also notice that even if I'm not zooming in, I don't see anything myself here. But you can clearly see that there is a path that's being highlighted here. This is automatically done by Blackfire, thanks to the time spent within the functions. And usually it goes down to these kind of nodes with a colored background, so that we can zoom into directly. So here it's like doctrine, unit of work, create envy. Okay, there is a problem with doctrine that we already spotted before, because we were creating way too much entities. So, but here we have a clearer overview. Just keep in mind here that there is no time base. It's only a relationship between the caller and the callee. The caller being the function calling, and the callee is the function being called. So the only thing that such a graph guarantees is that this function called this one 1,255 times. And that's enough to to get an idea of what's going on. So clearly here we are creating way too many entities. And actually, if I switch to another view, which is a SQL view here, I can have the details of the SQL queries. I also have this information, the number of loaded ORM entities. That's a lot. More than 1,000, that's definitely a lot, even though we have only 42 SQL requests, which is already too much. But yeah, it's not that bad. We have like 6.74 milliseconds on the different SQL requests, but we're creating way too many entities. So now that we identified this directly thanks to Blackfire, it just gave us an entry point. I can browse the call graph from the bottom to the top in order to find where in my application, which function from my application was the little butterfly wave that triggered the storm. So let's go from the bottom to the top, because here we're clearly in the doctrine internals, even though actually if I click here, I can see that we're creating an entity which is clearly the comments entity, clearly from my application. So let's go up. Yeah, still doctrine internals. Yeah, here we go. This is from our application, right? App service comment helper. There is something here, and get user activity text, which is being called by this template. I won't get into details of what's going on here, but clearly now we know where to look. We know that's where the issue is, especially because if you look at the numbers here, this function has been called 21 times, and called 21 times a persistent collection. We might be in the presence of an n+1, because it triggers the 1200 times the hydration process. So, well, we know where to look. Let's fix it. We fixed it. We deployed it. And now I'm going to profile again, the same one. It's a bit faster. Okay. Remember, we had like 300 milliseconds for the first one. Now it's 169. Yeah, we could say, hey, that's better. We fixed it. Good job. Let's find something else. Actually, no, it's not enough. We should definitely verify that what we did actually improved. Even though that sounds clear here, we might miss something. So in order to do this, I'm going to compare the profiles. So for this, I'm going to my dashboard. So that was my first one. This is the new one. So let's compare them. And here it is. Well, actually, we can see that we have a bad regression on input outputs, but well, actually, this is maybe the other number that wasn't really good. But yeah, we can see that there is a regression actually. Mostly it has been improved. We reduced by 44%, 56% for the CPU, and almost everywhere. In the SQL queries, you can see the differences. Here we don't have this one anymore. It has been replaced by a count. So we did have an n+1. And we can compare the dimensions as well. Everything that is in blue is an improvement, and everything in red is a regression. I don't have to zoom in to know exactly, but you can get into details. And here, well, everything is in red, so we did have a regression here. We could continue the investigation to understand why we have this regression and fix it, but that would go way beyond midnight. Right. So here is about the basics about profiling. And this is something that you will use, you will get addicted to. Each time you do something, you want to profile it, not necessarily to measure the performance, again, but to understand how your application works, because you do get all the details. And we can go much further, but that would go way beyond this presentation, and because I could speak about it for hours. Okay, so that was the profiling part. Now, what about monitoring and how monitoring and profiling interact with each other? Let's find out. So I'm going to jump on Symfony.com, health report. So Symfony.com has quite some traffic. So that's a good example here to analyze. Oh, there's something that I didn't show you about the profiles are actually the recommendations. So maybe I should start with that, because this is an important part. Let's have a look here. Recommendations. So here we have 11. So these are actionable insights. A few things that have been automatically detected by Blackfire based on your application. So it was we detected that a certain active setting has been actually enabled. That we are not using PHP preloading, when actually we do use PHP 8.1. And Symfony, well, if you're using PHP 7.4 or superior with Symfony, you definitely should configure PHP preloading. You would gain like 20%, 15 to 20% performance. And this, well, everything here goes with how to fix a documentation. So about PHP preloading, yeah, this is gives you insight on how to fix it. For Symfony, for Laravel, or other frameworks that you can use to fix this recommendation. And well, if you don't have any here, it means that you did a good job. But well, usually you will get some, and it's okay. You just know now what to fix. Sometimes they're more general, like this one. You should execute less SQL queries. Yeah, thank you, Sherlock. But it gives you examples of what you can do to reduce the number of the SQL queries. Same for creating the RM entities, etc. And these recommendations on the health report, we also find them. And here the recommendations are actually extracted from all the profiles that that were made on this Blackfire environment. So this is a live environment here, because even though they are extracted from profiles, actually when you're using Blackfire monitoring, you will get automatic profiles. I will get into that. This is an overview for the last 7 days and the evolution of the key metrics here, which are the 96th percentile response time, the median response time, the traffic number of requests, the number of errors, and the builds, so automated builds that I mentioned earlier, performance test. Yeah, I get an overview of the most impactful transactions, of the most impactful service calls. So here, the SQL queries. and the builds themselves. So as I said about the builds, these are scenarios that you can trigger like on a regular basis, like every 1 hour, for instance, on production. This is also what we call synthetic monitoring. But here, these data are crossed with monitoring data. And here it says that, well, your scenarios are good, but you also have transactions that you do not have tests for. So yeah, here this one, the doc controller doc action represents 26.7% impact. So meaning it's quite popular, and you do not have tests for this. Well, you should have a look. You should probably define a test here. So that's it mostly for the health report. Now monitoring. So let's go to the monitoring. By default here, we have monitoring data for the last 30 minutes. Let's have a look for the past week. Yeah. So the first filter that we have is a timeline here for the last 7 days that I can change, right? And you have 2 lines. The pink line represents the time, the wall time. So it's all the traces, the time spent processing all the traces. The blue line it represents the RPM, so number of requests per minute. So it's basically the traffic. You can change, like use the memory instead, and here using the server load or the output bandwidth, but usually I stick with RPMs and time. I can filter the context. By default, we're in web, but we can also have monitor CLI commands or consumers. Well, for Symfony.com, we don't have any, but just keep in mind that you can also monitor your consumers and CLI scripts. Well, filters on the host, filters on HTTP method, etc. So let's try to find, yeah, here. Let's try to find a bump. So I'm narrowing here. So the 2 bumps actually are, everything is filtered in real time. So this is the first bump. This is the second bump. We also have filters about HTTP status. So especially if you want to filter out all the 500s errors, you won't have full details on the errors, but usually when you have 500s, you want to have a look into it. I can, yeah, filter it, and it filters everything. So including the transactions themselves. About we also have the response time distribution. Well, here it's pretty excellent, but you might have some here that are above 1 second to process. So maybe I just want to focus on those ones. Still filtering understand what's going on, and the list of the different transactions. Global response time is the same kind of things that is the same thing that I showed on the health report. It's just that here it's live on a minute per minute here. Yeah, more or less, depending on the zoom level. So still the 96th percentile and the median time. So I didn't mention it. It's 96th percentile here is a statistic tool, right? It's not something that we invented. It means that 4% of the requests hitting your server are slower, but they are considered as exceptional, and well, therefore they're not displayed here. And it's always good to have to compare the 96th percentile to the median as well. The following section is about the response time breakdown. So they're extracted from the extended traces. So this is services monitoring. Here we're using mainly the database. So these graphs can give you an overview on how much your interaction with the database here counts in the whole application. In total here, for example, we have like 45 milliseconds. In average, we have 55, not 45, 55 milliseconds, and here 52 in the app itself, so meaning the PHP part, and that we have like 36 microseconds for HTTP and 2.33 milliseconds for SQL. But here we do have a lot more. Maybe we had a cache that has been expired, and that just increased the number of SQL queries and the time spent here, because we see that exactly where I stand. SQL queries represent 31%. 31 milliseconds, which is significantly more than everywhere else. And the last sections is about the top transactions and the top services calls. The top transactions, they are sorted by impact by default. So what is impact? Because I didn't mention. It's in percentage. And well, actually, this is a percentage of time spent processing this transaction, well, each transaction versus all the other ones. When we say time spent processing, so it means the time spent within a trace, but multiplied by the number of calls. So it basically says which transactions are the most popular. And if you need to optimize something, you should always optimize high impact transactions first, because they're more popular, and also because they're combined to the time. It might be that might be also slower than the other ones. Well, here let's have a look at let's compare the first one that has 38% impact with, for example, this one that has a 96th percentile of 220 milliseconds, but that has less than 2% impact. It means that you can decide with facts and figures what you should optimize first. So especially when you have a project from a customer and the customer says, well, you really need to improve this, the performance of this page because it's really slow. And thanks to this, you may say, well, okay, this is slow, but actually it has a lower impact than this other one, which is way more, which has way more priority then. So you can definitely, it helps you decide on what part of the application you need to optimize. And for the top services, it's exactly the same, but it's services oriented. So here we're only using SQL, a database. So it's all about SQL queries. So you can actually see the list of the most impactful SQL queries within your application, and that's great. I click here, I will have the list of the different transactions that are matching this SQL query. So these are precious information. And yeah, let's click now on a transaction. So here we'll have the same data, the same visualization, but focused on the transaction itself. We have like two buttons in addition. This one, the profile next request, and I will come to that, and the browse traces. If I click on browse traces, I can yeah, because it's too much. I should narrow down. Like, let's take the past 4 hours. Yeah, I can click on the different parts here on the timeline to have the details of the traces themselves, and therefore the exact URL that was called. Same for the response time breakdown, but here dedicated focused on this transaction, the top services. Here, this is something new, the spans. So this is what I mentioned as the key components interacting within this transaction. This is like a micro timeline. You might find that what we call spans here are quite similar to the timeline view that I showed. That's correct, except that we don't have the full details because we're only at the trace level, extended trace, but still, we're still at trace level. And to minimize the overhead, we don't take all the measurements here. But we can see that, yeah, we're using a Symfony controller. That where do we have PDO statements? Here, file get contents, again, PDO, etc. So key components that are really important. And automatic profiling. And this is one of my preferred favorites features. When you're using Blackfire monitoring, every 24 hours, Blackfire will come to iterate on your 10 most impactful transactions and trigger profiles from real end-user traffic automatically. So this might be counterintuitive because I said that the profile has a maximum overhead, and that's correct. But usually traces, like monitoring information that you're getting with the monitoring system are not enough. You really want to know what's going on within the application and how your users are using it, in which maybe they're misusing it because you didn't expect how they were using it. And that's why we do automatic profiling. So yes, the targeted user will have an overhead that is higher than all the other users, but this is like a surgical sample, right? It's only for one request, so that's perfectly fine. And also, you can manually ask Blackfire monitoring to profile the next request corresponding to this transaction. If I click here, click on profile next request, hopefully in a couple of minutes, I will get a new profile here. Usually it takes a few seconds to come up, but yeah, it's always like 1 minute or something. Not yet. It does work, I promise. Yeah, we have it. Here, less than 1 minute ago. This is exactly what I was asking for. Good. Now the last thing I want to show, that's quite a lot, right? But the last thing I want to show with Blackfire monitoring is the alerting system. Because you will not have always your eyes on the timeline for on the monitoring timeline. So, but you still want to be alerted when you have an issue with performance issue, whatever it is. And for this, I can create alerts. Like I can define some with high response time or too many errors, or maybe low HTTP traffic. Let's take the easiest one, the high response time. So yeah, I'm an advanced filter, but so I can just decide about response time, the average or the 96th percentile. I can target a transaction, which doesn't work. Okay. Nice. This is the demo effect. Yeah, you can filter using an expression language, which is actually the Symfony expression language, using the transaction name or the HTTP code or the host name. So if you're using load balancing and stuff like that. And the condition, well, if it's like above, above like 70 milliseconds during 5 minutes, then I can notify a channel. So I can send a message to Slack, an email, or PagerDuty or Opsgenie or whatever you want, even a webhook. You're free to choose anything. Something that can be useful is to define a webhook to trigger a build. So with the scenario, and profiling each step of your scenario, which would give you a good overview of what's happening when you have like a lot of traffic and actually you have issues, performance issues, and this is where it's important actually. Yeah, so to sum it up, Blackfire is now a complete observability platform. It covers both monitoring and profiling, and they work together. They're all combined. It's not like one feature on one side and one feature on the other side. Because the Blackfire monitoring will use the profiler itself to give you more insight. You won't have anything to do to get the profiles on the key transactions of your application, giving you real insights, right? That are really critical to give you, because it gives you vision on what's happening live. Now, I think some of you already use Blackfire monitoring, so it would be interesting to get feedback on that. I'm thinking about Christian, about you, Christian. So that's it. Thank you for listening, and I hope you enjoyed it.